Hello, welcome back to the video lesson again. Once again, I hope your quiz went well and you feel like you did a good job and that you understood it. If you did not, you are always welcome to come see me during morning break, during lunch, and if you need to come after school, let me know to make sure that I'm here or that I don't have a meeting. Otherwise, you can just stop by and see if I'm in my room and come see me then. Alright, so our final section is 5.7 on complex fractions. So what is a complex fraction? A fraction is a complex fraction if its numerator or denominator, or both, has one or more fractions or powers with negative exponents. So one or more fractions, that's a fraction within a fraction, or you have negative exponents, which then creates a fraction within a fraction. So when you go to solve or simplify these fractions, you can use two different methods. I'll demonstrate both methods for you in these first two examples, and then after that you should just choose a method and go with it, or you might figure out when method 1 might be easier or when method 2 might be easier, and you might switch back and forth. Otherwise, if you have more difficulty with these types of problems, I would choose a method and stick with it the entire time, because that consistency will make you more successful and will eliminate some of your careless errors throughout. Okay, so method 1. First we simplify the numerator and denominator separately, then we divide. So let's do method 1 with all numbers so it is more attainable and you can kind of see what's happening. So again, it says simplify the numerator and denominator separately, then divide. So we have this big fraction bar right here. So I'm going to simplify the numerator, then I'm going to simplify the denominator, and then when you have a fraction, so in other words, it's like I'm taking 3/4 minus 1/8 and I'm dividing it by 2 plus 1/12. So I need to simplify this first part. Well, how do I simplify the first part? I get a common denominator of 8. So this first fraction needs to multiply by 2 to get to a common denominator of 8. So I'd end up with 6. And then of course this already has the 8, so I get 6 minus 1. So that's my numerator. Then I'm going to divide by 2 plus 1/12. Well, that's simply 2 and 1/12, right? So I add 2 plus 1/12 and I get 2 and 1/12. But 2 and 1/12, maybe I should have written that as a improper fraction, so 12 times 2 plus 1 is 25/12. So now my next step is to simplify. 6 minus 1 is 5, so I get 5/8. And then when you divide by a fraction, you have to multiply by its reciprocal. Now, if I was still writing it in complex fraction form, this would have looked like it would have been 5/8 divided by 25/12. So going back to method 1 says simplify the numerator, well that's 5/8. Simplify the denominator, well that's 25/12. And then divide. So when you're dividing by a fraction, you multiply by its reciprocal. So I turned it upside down. Now I can cross cancel, because you don't have a calculator, remember, so it's good to do this canceling. 5 goes into itself 1 time, 5 goes into 25 5 times, 4 goes into 8 2 times, 4 goes into 12 3 times. Now I multiply straight across. 1 times 3 is 3, and 2 times 5 is 10. So my final answer for this complex fraction is 3/10. So that's method 1. Simplify the numerator, simplify the denominator. So in other words, I simplify the numerator, simplify the denominator, and then I multiply by the reciprocal to get my final answer. Method 2 says to multiply the numerator and denominator by the least common multiple of all fractions appearing in the numerator and denominator. So what method 2 is trying to do, it's trying to get rid of the fractions within the fraction. So it's trying to eliminate the fraction in the numerator, trying to eliminate the denominator of the fraction in the denominator. So I have 3/4 minus 1/8 divided by 2 plus 1/12. So this is the original problem. Well, if I look at all my denominators across this complex fraction, I have a 4, I have an 8, remember this has an invisible 1, and this is a 12. So what number are 4, 8, 1, and 12 all divisible into? So they're all divisible into what? 12? No, because 8 times something doesn't give us 12. So we double 8, we get 16. No, 12 times something doesn't give us 16. Let's triple 8, that's 24. 4 goes into 24 evenly, 8 goes into 24 evenly, and 12 goes into 24 evenly. So I am going to multiply the numerator and denominator by 24 over 24. So I'm multiplying the numerator and the denominator by the least common multiple. So why am I doing that? Well, I'm multiplying by 24 over 24 because that's the equivalent of multiplying this fraction by 1. And then I'm doing that so now when I distribute 24 times 3/4, well, think of that little side note. 24 times 3/4, well, what happens? I cross cancel. 4 goes into itself one time and goes into 24 6 times. So 3/4 times 24 gives us 3 times 6, which is 18. And then 8 goes into 24 3 times, so this would cancel and become a 1, 24 would become a 3, and negative 1 times 3 would give me negative 3 in the numerator. And that's it, my fraction's gone. So I just have 18 minus 3. In my denominator, it's 2 times 24, well that's 48. And then I have 1/12 times 24. Well, 12 goes into itself once, it goes into 24 2 times. So I would get 48 plus 2. Well, I have to simplify the numerator. 18 minus 3 is 15, 48 plus 2 is 50. And so then I divide everything by 5, and I would get 3/10. So we get the same answer. Okay, so if you didn't understand this distribution that I was doing, you just need to do little side notes, right? So negative 1/8 times 24. So I'm canceling the 8 goes in 24 3 times. That's how I got a minus 3 here. 2 times 24 is 48. 1/12 times 24, right? I cancel. 12 goes in 24 twice. That's how I get a 2 here. And then I simplify. So now let's do one that's with our variables instead of numbers. So that's our warm-up. It kind of brings back those memories of fractions, and you can relate to that because it's numerical values, and people tend to do a little bit better with that. So now we have our negative exponents. Okay, well, we know about negative exponents now. We just need to make them all positive. So that's step number 1. So I'm going to change x to the negative 3 into 1 over x to the third, plus y to the negative 3 is 1 over y to the third, and then x to the negative 1 is 1 over x, and y to the negative 1 is 1 over y. So if I'm doing method 1, I have to simplify the numerator and the denominator separately. So in this numerator, I need to find a common denominator. So on this top part of the fraction, I need to find a common denominator. Well, my common denominator is both x cubed and y cubed. So what is missing from this first fraction is y cubed, so I end up with a y cubed here, and what's missing from my second fraction is x cubed. So I have plus 1 times x cubed, which is x cubed. So there's my numerator. My top part of this overall complex fraction has now been simplified. Except I haven't factored, but we'll come back to that. My denominator, my common denominator in the bottom part of the fraction is xy. So what am I missing from this first fraction? A y. The second fraction, I'm missing the x. So I get 1y plus 1x. Okay, well now if I take a fraction and divide it by a fraction, I have to multiply by the reciprocal of this right here, the bottom part of the fraction. So my numerator is y cubed plus x cubed. Right? And that stays the same, but now I'm going to flip my denominator and multiply by its reciprocal, right? But that's why I'm flipping it. Okay, well we can see here, we can cancel, but we can also cancel here, but not until we factor this numerator. So I need to factor this numerator. Okay, well how do I do that? That's perfect cubed. Remember a cubed plus b cubed? How do we factor that? So now over here I'm going to factor this first one. So we take the cube root of y cubed, same sign, cube root of x cubed. We square this first term, it's the first term here, we change the sign, we multiply these two together, always a plus sign, square the last one. So that's how we factor a perfect cube. My denominator can stay x cubed, y cubed. Now the second fraction, there's nothing I can do to simplify, so I keep it just like this. Now I'm going to cancel. Well, this y plus x can cancel with this y plus x, so those disappear because they're identical. Remember, they have to stay in this parentheses. They're identical, so you cancel them. And then this is x to the 1, y to the 1. Well, this has 3, so we're going to cancel one of these and have 2 left. And we're going to cancel one of these and have 2 left. So my final answer is y squared minus xy plus x squared divided by x squared y squared. Can I cancel an x squared for an x squared, a y squared for a y squared? No! You cannot. Right? Not possible. This is grouped. This is one big number. As soon as they're being separated by pluses and minuses, they're no longer factors. We can't just cancel them with these factors down here. So we have to keep it like this. So this is my final answer. Got a little messy, sorry. It's y squared minus xy plus x squared divided by x squared y squared. So that was method 1. Method 2. Again, I start with my original 1 over x cubed plus 1 over y cubed divided by 1 over x plus 1 over y. Okay, so I'm going to multiply the top and bottom by the least common multiple. Well, my least common denominator. So I have an x cubed, a y cubed, an x and a y. Well, my common denominator with all of those denominators would be x cubed, y cubed. So I'm multiplying by 1 over 1. So when I distribute 1 over x cubed times x cubed, y cubed is just y cubed, because these would cancel, and I would have 1 times y cubed, which is y cubed. Plus 1 over y cubed times x cubed, y cubed. My y cubes would cancel, and I'd have plus 1 times x cubed. And then x, 1 over x times x cubed, y cubed. Well, 1x would cancel, we'd have 2 left. So I have x squared y cubed. Plus, this 1y would cancel with y cubed to leave it with y squared. So I'd have x cubed y squared. Now I can go immediately to the factoring stage. So I'm going to factor my numerator. Well, we just saw how to factor this perfect cube. So let's do it again. Then my denominator, when I factor, I need to factor out an x squared y squared, and then we'll see we have a y plus x left over. Well, is this starting to look familiar? This y plus x is identical to this y plus x. So my final answer is the exact same thing I got before, which is y squared minus xy plus x squared. Oops. Made a little mistake here. Made it twice. Sorry about that. So y squared minus xy plus x squared divided by x squared y squared. So to me, method 2 is a little bit cleaner, but maybe that does require more mental math. But I think the fraction within a fraction and keeping that through can get a little painful sometimes. But it depends. If you don't see the least common denominator for the least common multiple of everything there, then it's going to be tricky for you to do method 2. So look at both methods, try to decide which one you're going to work on, and then start these problems on the back. This is the stage where before you watch part 2 of this video, I highly recommend you try these problems. I will explain them anyway, but it might be good for you to kind of go through it on your own, see how you do, and then you can compare with me, or you can watch it if you get stuck and see how to fix it. Okay, so I will talk to you soon.